Welcome back to Leaving Cert Plus. This is lesson 1.21, our first lesson looking at factorizing and finding the roots of cubic functions. Remember, cubic functions have an x to the power 3 and they look something like this. So this would be a positive x cubed. So if I was to draw that on a graph, here's our x-axis, this might be your y-axis, and what we're looking for here is where that cubic function crosses the x-axis. Okay, so these are known as the roots. So the steps we need to take are as follows. The first step is you got to guess your first root. And how we go about guessing our first root is you look at this last number here, you pick a factor of that last number. So for example, 1 fits in evenly into that 72, like it does to every whole number. But what I need to do then is guess by subbing that in. So I'm subbing in 1 into this function here. So we've got x cubed, so it's going to be 1 cubed plus 1 squared minus 30 by 1 minus 72. So that's going to be 2, and that'll be minus 102. So that's going to be minus 100 altogether. So you can see that this is not equal to 0. Now, if 1 was a root, so if x was equal to 1 as a root, this would be equal to 0. So what we're doing is subbing in values that fit evenly into that 72 and finding which one of those values gives an answer of 0. And when we find one that equals to 0, we can then confirm that this is a root. So if we subbed in something like, maybe if we try 6, we're going to get another answer. So if you sub in 6, in this example, that will come out to be 0. If you put that into your calculator, you'll find that's 0. So what that means then is that x is equal to 6 is a root. But more importantly then, our next step is that we got to change that into a factor. So how do we change this into a factor? It's basically the reverse of what you're used to doing with your quadratics. We bring over our 6 and we've got x minus 6. So x minus 6 is a factor. So what that means is that it fits in evenly into this cubic equation. So what we're going to do next is long division with our new factor x minus 6. So I'm going to divide x minus 6 into my cubic equation, as you can see here, and just complete the long division. So we're well used to doing long division now. Our first question is, what do we need to multiply that x by to get x cubed? The answer is x squared, and then you multiply that x squared to get this line here. And it's just the same steps again and again as we have practiced. So you'll find you have a quadratic on top. What you need to do now is find your other two factors and other two roots from that quadratic. So you got to factorize that quadratic and then find your other two roots. So x is equal to minus 3 and x is equal to minus 4 are the other two x values where our cubic function, where our original cubic function crosses the x-axis. Okay, so looking back at the steps. First of all, we subbed in a couple of values that fit evenly into that 72 to see if it does equal to 0. And we found that when we subbed in 6, this was equal to 0, which answered our question that this is a root, and then we turned that into a factor. So we brought our 6 to the far side of the equal sign and found our factor as x minus 6. Now we divide in that factor into our cubic equation, do long division, and then we find we have a quadratic on top. You can factorize that quadratic to find your other two roots and your other two factors, and then finally your other two roots. Okay, so that's how you do it, and those are the steps you got to follow. We've got one example in this video, so I'd like you to pause the video now and try this final question. So first of all, our first step is to guess our first root. So if you tried a couple of answers, you might have found that if you subbed in 3 cubed plus 6 times 3 squared minus 13 times 3 minus 42, that comes out to be 0. So x is equal to 3 is a root, so therefore x minus 3 is going to be a factor. So what do we do with that factor then? We have to divide that into our cubic equation. So x minus 3 as a factor being divided into x cubed plus 6x squared minus 13x minus 42. So now you're doing long division here, so what do I need to multiply x by to get x cubed? The answer is x squared. So multiplying that x squared into these two, we're going to get x cubed minus 3x squared. Then you want to change the sign, so it's positive and positive, or sorry, that's negative and positive. So that's going to lead you to a 9x squared. Bring down your 13, that's minus 13x. So now you have to multiply by positive 9x. So multiplying both of those guys by positive 9x, that's going to be 9x squared minus 27x. Change the signs here again. So that's going to be positive 14x minus 42. So then you're going to have to multiply here by 14. So you're asking, what do I need to multiply that x by to get 14x? The answer is 14. So multiplying that 14 in here twice, you're going to get 14x and minus 42. So changing the signs there, negative and positive, you're going to get 0 as your remainder. So now we've got the quadratic on top, and to find all roots then we have to factorize that quadratic. It's going to be x squared plus 9x plus 14. We want to factorize here, and we're looking for roots, so we're putting it equal to 0. We could say x and maybe 7 and 2. You can say if they're both, that's a positive, sorry, so you could say both positive. So x is equal to minus 2 and x is equal to minus 7. Okay, so there are your two roots there. And that is joined up with your original root of x is equal to 3. So you found 3 roots there. So that's basically how you do the cubic equations solving for roots. So step 1, guess your first, change that into a factor and divide it into your original cubic. You'll get a quadratic on top, then factorize that and find your 2 roots. That's all for lesson 1.21, an introduction to our cubic function solving for roots. I'll see you again in lesson 1.22 where the questions get a little bit more difficult. Thanks for watching Leaving Cert Plus.
If you like this video, you'll love our notes. You can get some for free in the link in the description of this video.